Imagine. Imagine we build now our own artificial intelligence system from scratch and task it with two documents, Accenture's TechVision 2021 and Deloitte's TechTrend 2021. And we ask our system, can you sum up both documents for me? What is the difference between those two documents? And for an artificial intelligence system, this is one of the most complicated tasks you can imagine. Because you do not have a benchmark where you say, find me all the pictures that look like a car, or find all the reference to a certain word. No, there's no guideline at all for this system. Each document has about 100 pages, so it's about 3,000 sentences. And our artificial intelligence system has now to deduct the content of both documents and show us if there's any difference. Now, for us human readers, it is easy, because there's a clear summary where, for example, Accenture tells us architecting a better future is of significant importance to compete, because companies compete on the architecture. You have intelligent digital twins where you can simulate and where you can interpolate how systems gonna behave, how the ecosystem is gonna evolve if you modify. The democratization of technology, where all the high-tech tools are provided, are given to all of your staff. Each and every of your staff member can be the nucleus of some innovation. Anywhere, everywhere, bring your own environment. If you work from home, if you work on a different location, if you work with your supplier, if you work with different parts of your companies in different parts of the world. This is similar what Deloitte called never trust anybody. All the systems have to function everywhere, anywhere, on all different standards, and they have to be secure. And of course, a multi-party system, especially within COVID-19. The multi-party system challenge is one of a real challenge. TechTrends2021. Deloitte segments it in 9 parts. Of course, at first, turning to strategic technology platforms equipped with advanced analytics, automatization, and artificial intelligence. Also shifting core assets to increasingly powerful platforms, preferably in the cloud. Here, more value from the data they collect, analyze, and share across their supply network. You integrate your suppliers, your supply networks, to gain and access wealth from those connections. Discover patterns, reveal anomalies, make prediction and decisions, and generate insight. What a simple and easy task. Feeding the machine. Analytics to identify connections. The next generation cloud-based data stores to support complex modeling. Well, of course, if everything is done and everything is transferred to your digital intelligent twin, the cloud technology that hosts all your data, all your models, all your semantics, all your interconnections, all your boundary conditions, everything has to be at first secure, and you have to be able to give access to everybody of your participants within the innovation cycle. Never trust anybody, always verify all platforms, all structures. Remote work, of course, the natural extension. Digital meets physical. You have the impersonal experience and the digital experience, and they become more and more seamless and intertwined, and of course, diversity, equity, and inclusion. So this is the content we want our artificial intelligence system to summarize for us. So here we go. Let's build our own artificial intelligence. Since this is episode 5, I guess now you are familiar with the process we're doing. We're running through, we load our sentences, we load our BERT sentence embedding model. We choose BERT large. It's about 1.24 gigabytes of pre-trained embedding. It has been trained on the English Wikipedia. It's about 2.5 billion words. We write it to a specific data frame. And our sentences look like a data frame. We have for each in our sentence one row, and I distinguish here source 0 or source 1, depending if it belongs to Accenture or it belongs to Deloitte, because afterwards we want to be able to differentiate between those two data sources. Now we're going to run a prediction model. We apply all those pre-trained elements to our sentences, and we want to have an output level. This means based on a level sentence. This means, as we can see here in our data frame, we have 3012 rows in our data frame. Each row is a sentence. And based on BERT large, we calculated an embedding of BERT large in 1024 dimensions, feature dimensions. That's here summarized in a list. We can make it a little bit nicer to read. We can split it based on our 1024 dimensional coordinate set. We can merge it together with the sentences. We can save it to a file. We can even calculate the cosine similarity between those sentences. So let's say, for example, I have sentence number 15, and sentence number 15 is normal ways operating removed equation organization proved good wield technology, try new things, blah, blah, blah. And those are the sentences our artificial intelligence tells us that are close to this sentence. You can even define your own sentence and calculate what is the closest sentence that is, since my basic sentence is not part of the body of sentences, which sentence of the document is closest to my given sentences. So you can calculate the embedding of this single sentence, and it takes a little bit of time since we're operating on a BERT large. And we calculate also the cosine similarity for all the sentences and my extended embedding. And you will get, if I have my sentence leaders, machine learning and change, so 3 keywords and 1 bigram, the system answers me that these are the most similar sentences. And here you have the cosine in a decreasing order, where the system says, hey, those are the sentences within the body of text which are closest. Now, to reduce the dimensionality, we apply algebraic topology. I won't go into the details of the API of UMAP. It's a beautiful code. Execute it. It's done. We have 7,000 learning steps. Okay, it takes a little bit of time. We construct a fuzzy simplicial set. Remember, we are not operating in any Euclidean space, not in a Minkowski space. This is a pure topological space. There's no distance function defined because this is not a normal space. It's an absolute constructed abstract space, and we have to induce a metric. And this is done in UMAP, and it's beautifully done. And it's lightning fast. You do not have to go to PCA and TSNA and all the different steps. This will take care about it. We can perform some clustering of all our data points. And if we run through the cluster algorithms, we see here again, we have now 10 clusters, cluster 0 to 9. And within cluster -1, the system puts all the sentences that it cannot directly assign to any of the active clusters where the sentences are. So as a result, we have cluster -1 with 899 sentences not belonging to any other cluster. The system regards these sentences as noise. And then we have cluster number 3 with 448 sentences and so on. We can say, okay, here we go. For each and every cluster, we have all the sentences within the clusters. And if we're gonna have a 3-dimensional visualization, we run UMAP again. Now, of course, in 3 dimension, because we want to get the X, Y, and Z coordinate for each sentence. And we go here to 24,000 epochs. So come on, maybe we're gonna pause it for a second and I come back when the job is done. And about 1 minute later, you can see we run through all our 24,000 epochs. And what we end up with, each and every sentence has a clear cluster label. This sentence belongs to cluster number 5. And the X, Y, and Z coordinates of this specific sentence are given in this table. If we have this representation, the next step is a 3D interactive visualization of each and every sentence that is not regarded as noise by our system. And now the first is a visualization of Deloitte and Accenture's sentences. Each dot is a sentence. Each color belongs to Deloitte, and the other color belongs to Accenture. And the amazing thing here is they almost overlap. You have more than 2,000 sentences. And look at this coherent three-dimensional representation of all the sentences from both documents. And look how close they are intertwined. That is amazing. Why? Why do not have any outliers? Why is there not a spike out with a specific topic? Why there's not a stronger clustering? Well, think about what we done. We imported 1.24 gigabytes of pre-trained model information. So this means with all the knowledge of Wikipedia, all the sentences in Wikipedia, the specific topic of technology trends, technology foresight, what will come up in the future, in this year or maybe next year, the sentences, which are aggregation of word pieces, the tokens, which are not, which do not have to be words, but subparts of words. And if the words are not within the BERT vocabulary, they are reduced to their single letters. This presentation, given the training on the whole Wikipedia body, is a coherent set. Because it's about technology, it's about the change in company, it's about leadership, it's about the change in business structure, in architecture, how technology will become even more interwoven with our working environment, with our digital ecosystems. And if you think about other sectors in Wikipedia, physics, chemistry, politics, social sciences, whatsoever, the whole news cycle, they are so distinct that although we have two giants, Deloitte and Accenture, and they make their technology vision, their technology predictions, it is so similar. If you sum up on the level of sentences, their embeddings, which has been trained on a non-specific model for technology foresight. This is what you end up with. So this result clearly gives us an indication for our path forward, how we are going to improve our system in episode 6 and upwards. What are the next steps for us to improve the performance of clustering, of segmentation, of content? It's amazing. It's amazing. But you know what? Let's have a look at the cluster itself. We have calculated that there should be 10 clusters. So let's have a look. Start the visualization of the cluster. Yeah, that looks not so bad. Yeah, we have an outlier, a single outlier here. That's nice. Uncover accommodations, enterprise make employees, environment, missing space, including personal life, becomes part, workplace requires different accommodations. A strange sentence. Okay, definitely an outlier, even in my understanding of technology foresight. But otherwise, let's have a look at the cluster. What's an example? Understanding adapting factors differentiate customers' employee experience. Remote work becomes rule, exception, another focus, disconnect in-person remote workers. Hybrid work style, so this is definitely about something about COVID-related remote working. What about this dark blue one? Layered environment, human technology. Okay. Orange, is orange any cheaper, any easier for us to understand? Design changes, costs, time delivery cost, training time for existing supply chain, cost service. This seems to be a cost cluster. Training, Bitcoin settlement, governments, bank, overall, brand view, research value, global low code application. Wall Street, not really. The green cluster. Oh God, CIO, CSO, CTO, establish the democratized technology. Diversity, teams encourage inclusion. Technology limit organization strategic options. Yes, of course. See growing recognition across industries, strategic importance, running modern technology. Well, okay. Selecting important ecosystem partners, evaluate long-term motives, agendas, understand where the objectives, aspirations align. Okay. Executives believe organizations apply. Well, okay. Light blue. What's hiding behind light blue? Democratization, spark, ignite, transformation, people, microservice, revolution, forefront, partner across organization. Sure, couple important goals, focus building technical wealth, tech leader role, empowered strategy function, growing enterprise, reach responsibility, workforce becoming human. Wow, now this is something important, yes. Visit digital, new bespoken, okay, interesting. So the cluster seems okay, all right, makes sense. Of course, it is not a clustering of the strategic executive sentences like the document would have been received by a human reader. But since we are training an artificial intelligence system in less than 10 minutes on this system, it is amazing what it comes up with. But of course, remember, we have another possibility. We look at the words, at the bigrams, at the trigrams of all the sentences within a cluster, and we say, hey, what are the top 10 words, the top 10 bigrams, the top 10 trigrams of all the sentences within one cluster? And here we go. So if these are the top words, the top bigrams, the top trigrams of all the sentences within a cluster, just let me remind you, those are not sentences that make sense here at this level. Those are just word segments we extracted because the system regards them as essential to all the sentences within one specific cluster. So in cluster number 3, we have low-code, data scientist, real-time, cloud-based, legacy systems, machine learning, multi-party systems, edge computing, code platforms. All significant wordings, but the meaning of those words is somehow lost because our aggregation level is not a sentence which makes sense for a human being or a sentence which an artificial intelligence system reconstructed based on a reoccurring pattern that it learned. These are sentences that define a new system, a new future, a new structure, if you want. They could not be learned. They could not be extracted from the data. So it does not make sense even reading them to us, but we as humans, we have to use a lot of our imagination and a lot of our free association to understand how the the artificial intelligence clusters this. Cluster number 7, the tech leaders, the persons, the strategic choices they have, the technology strategies they can employ, the technology capabilities they have within their companies, within their ecosystems, the diversity and equity and inclusion, the workforce of human beings, the business case they generate with their available technology, the diversity, the equity, the inclusion, the technology they apply. This makes sense if you not just read those words and word pieces together, but you have to have a basic understanding of the system. And then those wordings make sense. They make sense to you as a human being. So the artificial intelligence system, 10 minutes trained, could give us an indication what are the clusters, what are the topics. But make no mistakes, if you're not familiar with the ecosystem, with the dimension, with the choices, you might end up in a complete different alley. Cluster number 5, supply chain plural, the cost centers, real-time supply networks, the digital twins that also digitally copy, encode, predict the outcome of ecosystems, they predict the maintenance, the digital twin as the intelligent twin where you can make projections into the future, how they will interact if you modify components of the other interlinked system. Interesting that we find a cluster here. Well, of course, the main cause for all of this remote work at home, working home, COVID, the digital workplace we all experience right now. I guess we're all remote workers. The ways of working change, work-life balance change, the employee experience change. We are a remote workforce, but we are extremely interlinked and heterogeneous. So the tools to create for this fascinating cluster. That sounds interesting. Zero trust security. Cluster number 4 clearly focused on cybersecurity. Never trust anybody, never trust any system. How can we secure our security, the security of the network? Accountability, transparency. How can we trust the security? The zero trust mindset. Well, interesting. Ingredients to the new remote workforce ecosystem that we all experience right now. Cluster number 1, the technology vision. We use the cloud for wealth management, supply chain. We integrate the supply chain. Each and every element is zero trust element based. Okay. Cluster number 0 is an interesting one. The yin-yang of physical and digital. We have the digital interactions and the human experiences in our physical world. But we do not only have the physical world, we have at the same time, we have everything copied in the mirrored world. Everything is in software, everything is expandable, everything has a digital experience. We can code all the different interactions that are not happening in real world cases. We can find new ways to create wealth, to grow a company brand, to experience. Interesting. Cluster number 6, COVID, the pandemic, supply chain, post-pandemic workforce. Which steps to be taken, the response to the COVID, to the pandemic. Rapid digitalization. The office is dead. Well, that's a not surprising insight. Added responsibility for each and everybody who provides wealth to the system. The pandemic organizational structure. Another time, digital transformation, technology, democratization. If we provide all our workforce with new tools, with new technology, with improved technology, with new interconnected systems, if we integrate our workforce, and as a quote-unquote leader, How does the human being integrate in this digital transformation, in this mirrored world? What is the vision of the future? Working in a virtual environment and at the same time being here in this physical environment. That's an interesting how you motivate workers. Executive report, technology-driven solution, of course, since it's more or less based on the technology, the way we interact, connect intelligently. That's an interesting cluster, cluster number 9. And cluster number 8, the smallest cluster, supply chain, tools, the supply, deal with the crisis, supply chain teams, the digital twin, discuss reports. And you can see, given the answer of the system, it's a highly interesting answer, but you have to have a broad knowledge of the ecosystem that is described, and you have to make sense of the segmentation the artificial intelligence presents to us, or the top wordings the AI presents to us, or the clustering the AI presents to us. To make sense of this distribution of clusters and why it has this interesting, almost homogeneous 3D sphere. Those questions are going to be answered in our next episode when we try to improve the system, our artificial intelligence system, even further. Thank you.